Okay, so here's where my work on the Joule Ringer is currently at. Sorry for the long delay in an update. I get a lot of complaints about the screaming sound on my transformers. If you don't like that, I suggest you just go to laserhacker.com and read about this, or turn the volume down. But anyway, folks, I got this working with ferrite. So we can now use a ferrite core, and we don't have to use the met glass core. That's really good news, because I'll give a source on laserhacker.com, but we can get these ferrites for a couple dollars and make these up. The other good news, I've gone to using doorbell wire. So that's a whole lot cheaper. A roll is $4. You can make one of these with a roll of this. It's 20 gauge. So big improvements. This will be a lot. And the other exciting update on this transformer is very, very easy to wind. In fact, that's the easiest transformer to wind out of any of them that I've made yet. So anyway, just thought I would show you an update where we're at. Let me put a different load on here, see if I can get this thing a little quieter. And I'll go over some of the unique things on this particular Joule Ringer. So let me just switch the load here to an incandescent. Let's hook this back up. There we go. That's a little better. So depending on the pressure you put on this, you can change the sound. But this is a 40-watt incandescent bulb. The nice thing about this current design is it adjusts to its load, and there's only a single component. I'm really excited about this one. One single component, just a transistor, a ferrite E-core transformer, and this super cheap wire. You know, it's under $5 a roll, and you've got a Joule Ringer setup that can give you practical power off the grid. You can charge up a LiPo with a solar panel or whatever you want. I've actually used lithium-ion batteries in my solar panel system. Let me just switch over to this other bulb here, and you can see what that's like. There we go. And now we have a single bulb on here. And so far in my test, I hate claiming anything about efficiency, but so far in my test, I plug one of these 7.5 watt bulbs into an inverter, and I measure the amp draw through that, and then I measure it through this system, and I get a whole lot less current draw through this system than my inverters that I have. And I'm sure maybe somebody out there makes a more efficient inverter, but I haven't found one. And the nice thing about this is you can build one of these up now for just a few bucks, and that's hard to beat. Let's see if I can get it going again. Sometimes you have to tap the connection when you're connecting this a little bit to get going. There it goes. Maybe I'll just show you how this little circuit adjusts to load here as well. So let me unscrew some of these, and I'll plug it back in to this, and you can see I'm really impressed with this one. Again, like I said, the fact that it's just got a single component, one transistor, and it is not a tip-off 0401 transistor, folks. That's very important to note on this. Yeah, let's just hook this back up over here. There we go. So now you can hear it. It's running one bulb. It's really resonating well. And what I'm going to do is I'm going to screw in some other ones, and you'll hear how this adjusts to the load. It's pretty interesting. So now we have two, and we'll just keep going down the line here. So there's three, and you can hear the sound is changing. It's interesting. It's four, and I'll just speed up here on the others. One, two, three, four, five, six, seven, eight, nine, 10. 10 of these bulbs, and you can hear there it's kind of fallen out of resonance to different pitch. So I'm going to take out a few. let it pop back up. There, you see it got brighter. Let's try it run 6. So there's a 6 on, and that's nice and bright, and this little guy's just ringing away here. So one other thing that I'll do is I'll shut this off and I'll just show you how I wind the transformer. Okay, so what I'm doing here is I'm winding 2 of these wires. You can see one's green and one's blue, and they're going to form my first layer. Okay, so there you go. You can see 1 layer, folks. And of course, if you want to connect this in as a Joule Thief style winding, you would just take the blue wire and connect it to the green and connect your positive lead right to there. We're not doing it that way in this particular Joule Ringer, but that would be the way. And you could connect this up like this, and this will run as efficient as the Super Joule Ringer that you saw in my first video that I've gotten so many requests on. Everybody's always asking, where can I buy that Met Glass toroid? That seemed to be the one and only that I found, folks. It was on eBay. But with this and some cheap ferrite, I've been able to beat the brightness of that one with less current draw. So don't be intimidated thinking you need that particular Met Glass toroid. It's not the case. You can use one of these. So now I'm just going to come on here with this again is just so simple in this one. I'm just going to come on here with a layer of this now. Same wire, same gauge. Maybe I'll choose a different color because I got a lot of this wire laying around, but I'm just going to come on here and just fill this up to the top of the bobbin until I hit this edge radius here. So depending on the bobbin, or whether you make your own bobbin, we'll just fill this up with that wire. Same direction on the turns, everything's pretty much the same. So I'll do that. Tell you what, we'll go ahead and build this one up, go over and hook it up, and see how it works. Okay, so winding on the beginnings of the secondary coil. So you can see you just wind this on here. This again is incredibly easy Joule Ringer to make compared to the other designs that I've experimented with. So yeah, you just this is the first layer. So when you get over here to the edge, you want to fill it up right to the edge, and then just start over with keep winding and just come right back across the other side. Let's see if I can do this while holding the camera, but yep, there we go. So just back across the other side. So I'm going to finish this up, folks. Okay, so I finished it up. You can see I got in a bit of a rush. It's kind of messy, but we'll hook it up and see how it works. Okay, so I've hooked it up to the bulb here. We got it connected here with the transistor, and let me set it over here. Let's power it up. There we go. So this little transformer just took us minutes to make. I've never had a design that works so easy to experiment on, try different size E-cores, different size ferrites. This is the big one I had in the video earlier. I got this one from Surplus, Nebraska Surplus, if I remember right. And man, this one really puts out some juice. I'm going to hunt down some of the biggest ferrite E-cores I can find on eBay. I've seen some really interesting effects, folks, with the insulated wire. I know the magnet wire is insulated, but this has a larger insulation covering. I think that's part of this, but I'll tell you what, let's hook this little guy up to an incandescent bulb and see what we get. Man, I wish I had more time to post a better video. I have seen some really interesting things. I've never been able to light LED or incandescent bulbs with a Joule Ringer type design very well. On this design, I've been able to get the bulb glowing at 10-20 milliamps input, and that's a dim glow. I'm not saying it's bright like this, but I've been able to get it glowing at that. I've been able to get the bulb running like a Joule Ringer off a capacitor instead of a battery at some very low milliamp draws. And then depending, hey, notice folks, this one's running very quietly. So that's interesting. But so for the future update video, one other thing. This is a coil of the iron floral wire that Lid Motor and myself have been using in a lot of experiments. I just wrapped this in a large coil. And when you get this in the right place in this circuit, some pretty amazing things can happen. I've also experimented with putting a full wave rectifier in line with the load. and connecting that back up to the source, you can get the lights a lot brighter sometimes, depending on how you configure that. Also been experimenting obviously with these coils with spark gaps and grounding the system. But yeah, I've been seeing a lot of exciting things, but just thought I'd want to share the basic, putting all this other stuff aside, the basics of this are so simple, but with using this cheap wire, you know, $5 ferrite. I'll post links on my website, laserhacker.com. I'll also post the schematic for this. Check it out, folks. I'm going to... Okay, I had some old 9 volts bouncing around here in the shed, so I thought I would try running this new one that we just wound up on 2 of these connected together. And I thought I'd show you something. A lot of times, I'm touching right here a lot, but a lot of times to get this circuit running, and especially when you're winding new transformer coils, you may have to tap. So just because you make the connection doesn't mean the circuit's going to run. Like right now, I'm connected. I have a good connection, but it's not running. So it is necessary sometimes to tap the circuit. You can see there, it's being finicky. There it goes. There. So I just thought I would point that out because there's a potential case in which somebody could build up one of these, connect it up to the battery, even like have it all perfect, and think, oh, it's not working. And it may work just fine. You may just need to tap the connections. But yeah, incredibly simple circuit. You can see that one lead of the lines coming over here to the light. It then comes over here and comes back to the transistor. You can also run this to a ground, just a rod out in the ground. That's kind of interesting to try. This runs to the negative. We have the positive coming in over here. We have this line coming over here into the transistor, and the secondary line coming over into this side. Very simple. I love not having any excess components, and I really love being able to light incandescent bulbs off with such an efficient system. Tell you what, let's try hooking this one up to. It's just so much fun. This is how time gets away from me when I'm doing this stuff. I want to try connecting this up to the 6 LEDs that we had running up here earlier. See if this little guy that we just wound can light these up. Yeah, look at that, folks. That's the one we just made. That's this little guy. I think the big one there's better, but look at that. We wound that up in just a couple minutes, a couple dollars in ferrite and wire, 2 9-volt batteries, and we've got 6. This is very much replicate at your own risk, as are all my experiments. I've been shocked good with this one many times. This little guy really pumps out the power, so you've got to be careful. I can run this 24/7 off my solar panel setup and have lighting out here. And to be able to do that and to do it simply, I think is important. So yeah, laserhacker.com. You can check out the schematic. I'll post links to sources on all of this stuff. I was just carrying this in the house and decided to hook it up, and I was just imagining that I could see myself in some dystopian future using this as some sort of flashlight. That it's running very quietly, folks. So it is possible to get these to run quietly. It's just, you know, finding the right load, coil size, things like that. But anyway, just thought I'd point that out. Man, this makes a great flashlight. So anyway, let's all keep experimenting.